Hello everyone, my name is Tehzeeb and I am an animation educationist from Mumbai. So very happy to meet you all. We're going to learn a little bit about animation and we're going to do two exercises. One is phonotrope and one is a flip book done in a notebook. So we'll come to that later. Let me start off a little bit about the basics of animation, a little bit about the history of animation, how it all started. So many years ago, in the 1800s, in 1825, there was this physicist called John A. Paris. He invented a thaumatrope device. This is a thaumatrope. This is an optical toy. So in the 1800s, children didn't have television, they didn't have their PlayStation and their Game Boy and their Xbox. And what do you think they did? They had nothing to do, they were bored. There was no television, there were no movies, there was no Cartoon Network. So they played with toys like these. This is a thaumatrope and this is how it looked. So you can see there is this caveman on one side and on the opposite side, upside down, is this cage, right? And we'll have to see whether this caveman fits inside the cage. Let's see if it works, okay? So I'm going to spin this. And does he fit inside? Oh yes, he does, and he's holding those bars, if you can see. So what's happening here? There are two images, and when I move it very quickly, it looks like one image, right? Now how do you think that is happening? What is happening? So our brain has a power to blend pictures, to merge them and make them look like one when they're moving at a certain speed, right? So, so there are two pictures, and what our brain does is remembers this picture for a fraction of a second, and very quickly when the next picture is seen, it merges and blends both the pictures. And that quality that we have is called persistence of vision. It's the power of the brain to blend pictures. Okay, so how many of you all know how cartoon films are made, or any films? How do you think they're made? So in cartoon films, an animation artist has to make 24 different drawings, right? So 24 different drawings for 1 second of movement. So how fast does 1 second go? You blink an eye and the 1 second is over. So how does it look like one continuous movement? Do you see 24 different drawings there? No. You see a continuous flow of images, right? It's a continuous movie. So that happens because our brain, when it's playing at a certain speed, our brain blends the pictures and gives the illusion of movement. That's how animation is made. So let's say an animator has to make 24 drawings of the hand moving from year to year. He will put one drawing here, 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 one drawing here. And when all these images are drawn and played on a computer or on a screen or on a projector, it looks like the hand is just moving across the screen, right? So that is how animation films are made. So let's go further back in time, 35,000 years ago, when man was living in the caves. And in the caves, when he was living in the caves, he tried to recreate whatever he saw around him. He tried to create the trees, the rivers, the mountains, the flowers, and he made sketches on the cave walls. But he also tried to recreate movement. And when he saw animals moving, he tried to create animals with 4 pairs of legs, as you see in the picture. In 1600 BC, there was this temple of goddess Isis that had 110 columns of goddess Isis in different positions. And when horsemen and charioteers rode past it at a certain speed, it looked like goddess Isis was actually dancing. The ancient Greek pots also had sketches on them, and when you spin the Greek pot, it looked like the man was running. So humans were trying to create movement even those many years back. Now we were talking about persistence of vision and how film works, how animation works, and how animation films are made. If you go to a film screening, you see that the film strips are put onto a projector which is then projected on a screen. But when you look closely at the film strip, they have individual images. So even live action films and animation films have a series of images which are then played at a certain speed, and because of that speed, the brain blends the images and gives the illusion of movement. And that's why we can see films on screen or on television. If we didn't have this power of persistence of vision, we wouldn't be able to see films, we would be able to see individual images. So what are the other examples of persistence of vision? So persistence of vision is all around us. So look around you, see if you can see examples of persistence of vision around you. Something that looks different when it moves fast, and when it's still, it looks different. So the first example that comes to my mind is a fan. Okay, if you look up at your fan in your room, you will see that it has 3 blades. But when you switch it on, it looks like there are hundreds of blades there, and it looks like a big round circle. So that is one example of persistence of vision. Can you think of more examples? So after the thaumatrope comes the phenakistoscope. Now this is a very interesting device because you can't just see it like that when you turn it around. So you have to hold it with a stick and it turns around, but you can only view it in front of a mirror. So you can't view it like that. So I'll just share some demonstrations of this, but we're going to discuss more about the phenakistoscope, which was invented in 1832 by Joseph Plato, a little later, because the phonotrope that we're going to be creating is very similar to this one. In 1834, this beautiful optical device was invented. It's one of my favorites. It's called a zoetrope, and it was invented by William George Horner in 1834, as I said. And it has this series of, again, 12 images, and if you look through the slot, it looks like there is a movement. So you can see this man, he's rolling over. So we'll show you a demonstration of that. And then comes this one, which was invented in 1877. All these were invented in the 1800s. And this is called the praxinoscope. This has the mirror, if you can see there's a mirror. And again, it has a strip very similar to the zoetrope. Okay? And this, when it spins, you can see the images. You can actually see the images, the movement in the mirror. So we're back to this phenakistoscope. The reason we are back is because we're going to be creating something very similar to this. We're going to be creating a phonotrope. A phonotrope is going to look like this, and it's going to be shot under a camera. Now you guys are going to shoot the camera after you all make your drawings. We're going to make 16 drawings on a paper plate. So I hope all of you all have a paper plate, a blank paper plate like this at home. We're going to create the 16 divisions on this paper plate, and then we're going to animate. So today's task is going to be only to create the divisions. But before we make the divisions, we'll have to find the center of the circle. How are we going to find the center of the circle? I wonder how. So we're going to find the center of this paper plate, right? So you can see this sharp corner of the paper plate. That's the edge that we're going to use, and we're going to draw two lines. Okay, so I have a ruler here and I'm going to find two lines. So I'm taking a line which is around 8 inches. I'm going to make a line. So this line is 8 inches from one edge to the other. Now I'm using a pen, but I want all of you to use a pencil because we're going to erase these lines later on. And the center of 8 inches is 4 inches. So we'll make a marking for the center. We need the center of this line. Again, at a different angle, we will again take 8-inch line from one edge of the paper plate to the other edge, and we make a line which is 8 inches, and we mark the center which is 4 inches. So we have these two lines. Again, please note that you will be using pencil here and not a pen, because we're going to erase this later after we find the center point. Then you take a protractor. This is a protractor. So many of you may have used this in a geometry class, and you get a 90 degrees. 90 degrees is a perpendicular line. So you mark 90 degrees here, and you mark your 90 degrees over here. Once you have this, you can take a ruler and connect the center point of this line to the 90-degree marking that you have made, and you draw a line that goes straight. And then over here you draw another line that connects the center of this line to the 90-degree marking, and so you have found the center of the circle over here. This is your center point of the plate. Now we will erase these lines. We will keep the center and we will erase these lines, because all we needed this was for the center point. So as I have mentioned that you have to take 8 inches here and you have to find the midpoint. So we found 4 inches. At 4 inches we made a perpendicular line. But this doesn't need to be 8 inches. It could be 6, it could be 7, it could be 5, it could be 9, it could be any length. But it has to be from one edge to the other edge. And you have to find the middle point. So if you're taking 9, the middle point will be at 4.5. If you're taking 8, it would be at 4. If you take 7, the middle point will be 3.5. If you take 6, the middle point will be 3. So this line could be any length. So you can place it anywhere on the circle. So it could be longer or it could be shorter. These two lines do not have to be parallel. So they have to be at an angle. So you have to keep these things in mind when you are trying to find your midpoint. So this line could be of any length. You find the midpoint and then make a 90-degree line from both midpoints, and where they meet is your center point. So here we have our center point, and we're going to erase the rest because we don't need these lines anymore. So we found the center and now we don't need these lines. So we're just going to take them out, and we're going to have a clean paper plate again with the center. So now we have a center and we don't have any other lines over here. Again, you will use a pencil and not a pen, and you will draw a straight line which runs through the center. So just make a line which runs through the center, but please use a pencil because we will erase these lines once we complete our animation. So this is one line that we drew across. Now we need a line that goes perpendicular to this line. So again, we'll take a marking and we'll mark 90 degrees. So you see, I have to keep the protractor on this line very carefully and mark my 90 degrees here, and I turn it around and I mark the 90 degrees here. So now I have just 4 partitions. So we have 1, 2, 3, 4, and we need 16 parts to this phonotrope. So we'll have to divide it further. So you'll go back, and now you will put it on this center point and you will calculate how many degrees is there, right? So you see, this is 40 to 50, 10, 50 to 60, 20, 60 to 70, 30, 70 to 80, 40, 80 to 90, 50 degrees, 90 to 100, 60 degrees, 100 to 110, 70 degrees, 110 to 120, 80 degrees, and we have 120 to 130, 90 degrees. So what is the 50%? What is the half of 90 degrees? It's 45 degrees, right? So we'll take 1, 2, 3, 4, that's 40, and 5, and we make a point here. Similarly, we go here, and again we put the protractor here, and we again get 45 degrees as a center point. 10, 20, 30, 40 and 45 degrees is the center here. Here we go and we create again 10, 20, 30, 40, 45, and we create a marking here, and we go and we create another 10, 20, 30, 40, 45 on this side. Now when we draw our lines, we get 8 partitions. So we have 1, 2, 3, 4, 5, 6, 7, 8 partitions now. Now the younger ones, if you're 10 years old and you're finding this, that you want to do only 8 frame animation, you can go ahead and make an animation film which is 8 frames. But if you're older and want to try something more tricky and more interesting also, you can do 16 frames. So I'm going to divide this further to 16 frames. And then I will show you both the options, an 8 frame animation and a 16 frame animation, and you can decide what you want to do. Now I've kept my protractor, if you notice, on this line, okay? So it's aligned with this line, and we know that this is 45 degrees. So what is a half, 50% of half of 45 degrees is 22.5 degrees, right? Half of 45 is 22.5. So 10, 20 and 2.5 would be somewhere here. Similarly over here, 10, 20 and 2.5 would be somewhere here, right? And you have again 10, 20, 22.5 would be somewhere here, and again 10, 20 and 22.5 would be somewhere here. So you have these divisions. Now you turn your protractor around and you keep it again aligned on the other side, and again you go 10 degrees, 20 degrees, 22.5 10, 20, 10, 20, 22 and a half. Again you do 10, 20, 22 and a half will be here, and here you go 10, 20, 22 and a half will be here. Once you have these lines, these dots, all you have to do is connect them and you will get your 16 frames or 16, and you'll notice that all of them pass through the center point and you will have your 16 frames here. You can take help from someone in the house and create the 16 divisions on your phonotron. Remember, you have to make it with a pencil. I have used a pen, but you can use a pencil. It's better to use a pencil so you can erase the lines later. Do not use a pen. So we'll be done with this, the divisions, 16 divisions. If you get even 8 divisions, it's fine, you don't have to worry about it, and you can do animation which is 8 divisions or 8 frame animation. The older ones can do 16 frames, the younger ones can do 8 frames, and it's absolutely fine. So I hope to see these tomorrow when we do our Zoom session, and it was a wonderful session. I really enjoyed myself and I hope you did too.